Initial trauma and injury cascade. Traumatic brain injury occurs when severe impact causes the brain to crash into the hard bones of the skull. Rapid acceleration and deceleration of the brain create shearing forces that tear open blood vessels and damages brain structures. Local disruptions in the vasculature can cause some areas of the brain to become ischemic. Later, as blood flow is restored, these same areas can suffer further damage during reperfusion, which is associated with oxidative stress and inflammation. Traumatic brain injury induces a cascade of secondary effects that are felt throughout the body. In the brain, the damaged neuronal tissue reacts by secreting a hormone signal called VEGF. At the neural synapses, normal communication is overwhelmed by excessive secretion of the glutamate neurotransmitter. The flood of glutamate opens receptors on the postsynaptic cell, causing extracellular calcium to rush into the cytoplasm. While this is happening, the membranes of the cell's oxygen-stressed mitochondria are beginning to rupture. The broken mitochondria release cytotoxic factors and another flood of calcium ions into the cytoplasm. The combined effects of high intracellular calcium and cytotoxic factors are strong enough to cause some neurons to undergo apoptosis. These dying neurons will not be replaced, resulting in permanent brain damage. In those parts of the brain that are closest to damaged vasculature, the breakage of the blood-brain barrier allows blood components free entry into spaces that are normally restricted to brain cell tissue. Macrophages from the blood have become activated by the injury, and they secrete inflammatory molecules that cause further stress to neuronal cells and their myelin sheaths. This cascade of responses to traumatic brain injury often occurs in multiple areas across the brain, and the damaging conditions can persist and even increase in severity for a length of time after the impact injury.